I know there's a lot of seniors in here, but I'm looking at you guys as my calc people coming up. So what that means for you is that we have to work on more problems. We have to be able to know what a graph looks like. For instance, you know, if I mention a quadratic, you need to understand how it would look like that possibly. And also to read math. So we are starting at the very beginning, and we did talk about a couple things the other day. So one of those things was this symbol. And what do we say that symbol is? Do we remember? Subset. Thank you. And, Nolan, we said I use like a subset with NFL. Do you remember what that analogy was?
NFL?
In the NFL. What was it? Does that make sense? So we got this group that's a subset of a bigger group. Okay, so right, the AFC is a subset of the whole NFL. Now, if you just wanted the Bengals, you would say they are an element of the NFL. And so if you're using this symbol, they both have to be some kind of set. It could be as easy as, right, Bengals, Browns. That's a set, and they could be a subset of the NFL. They could also be a subset of the AFC. So how's that? Is that okay? All right, so what else did we talk about? We did all the sets, right? We did like integers, whole numbers, etc. Okay, so do we say, so is this, if that's integers, is it true that integers are a subset of the real numbers? And so what you're thinking is every element of this set contained in this set?
Yeah.
And then it's true, right? Okay, so is that okay with everyone? We kind of remember that?
Yeah.
All right, so open up your books. You want to get on to page 3. Page 3. And down at the bottom of page 3, it's kind of blurry up here. Because one of the things I think I said this, maybe I didn't say it, but I do want you to be able to read math, at least on a level that can get you by. So we have this notation over here. You can't see it, that's why I want you in the book. We have this new notation over here, but it's on notation that you've seen before, which would be over in this column. So look at that for a second. And I'm going to give you an example. Okay. And using the new notation, and the new notation is that first column, so we're talking about these are square brackets or closed brackets. Oops, sorry. Square brackets or closed brackets. These are open brackets. And then you could, of course, have combinations of the two. So, who would like to try to translate this using these symbols? Who wants to chat? Make sure you're looking in the book, right? Something that you probably haven't seen. I know all you guys I had last year, I may have said something about these at one point, but I was okay with if you stuck with this. But I don't even think I even brought that. I don't even think I brought this up with you guys last year. So give me an idea, right? We're using 2 and 7. You gotta look at the book. You got some A's and you got some B's. Look down there. What do you got, sir?
So the open bracket, so, yeah, then 2, well,
Yeah, so far, yep.
yeah. Finish 2 and 7,
2 and 7, and then we're going to end it with,
close bracket.
is that okay with everybody? He's right. Is that okay? Yeah.
Is it closed because that line's under it?
That's correct. So, right, again, what this is saying is we're talking about every single number in between these two numbers, but not two. But yes, so, okay, that's what this is going to say also. So, since x is just an arbitrary number, when you're talking about an interval, you don't need to put it in there. You do have to understand when you're looking at an interval, because if it was this one, it can also look like a coordinate system. It's like how x equals kind of thing. Is that okay, everybody? All right. Should we do another one, or are you happy? Another one. All right. Let's do. Let's just do. Here, we'll make this one 0 just for fun. All right. So the question is -3 part of our interval here? Yes. Is 0 part of our interval?
Yeah.
Yes. So then which kind of brackets are we going to use?
Closed.
The closed. And so then you're saying these two things are saying the exact same thing.
Yeah.
Yep. All right. All right, flip the page over. I'm at the top of page 4. They get a little bit more, so I'm going to erase this part. We'll do two different ones. Oh, where'd it go? It's on there, I swear. There's one. And then we'll do that one. So up at the top, they kind of give you some more. Still talking about the closed brackets and the open brackets, square, rounded, however you refer to it, I'll be okay with it. I know all your names, except for you, Lord. I know you now. Woohoo! I'm going to give me a shout on the first one, according to what it looks like at the top. Top page 4. Another shot at, sir. What do you got?
So open bracket, 6, and then infinity, and then open, yeah, open bracket.
Is that okay? All right. What about the next one then?
Closed bracket. Infinity. Closed bracket.
Okay, that's close. Huh? Should be open. And then there's something slightly off over here too. Because it should be negative. So if you're looking at the top there, page 4, you should notice that all the infinities have an open bracket. Can someone explain why that makes sense? Right? Infinity actually isn't a number, it's some idea of a number. Okay, so you can't get there. You can never are there, no matter what you do. So you can't include it as part of your interval. Is that okay with everyone? So then, keeping that in mind, what is this statement saying? We used to call this something different. Okay, kind of ish. We used to refer to this differently. We would say this is for rhymes with bull. And then the second word begins with an R. Was it? Yeah, you got all reals. Thank you. I forgot. You're very good at that game. I remember now that you got that game down. Right, we use it like that. Right, that's the same statement. All reals right there. How's that? Is that okay with everybody? Okay. So, it's actually not going to show up today, but I want you guys, not today, but very soon, I want you to use these instead of these. Okay? Let's get away from this and let's get into this. Is that okay? Well, whether or not it's okay is irrelevant. When I say okay, I mean agree with me. All right, so moving on. Again, I want you to read math. So, how many people know what the definition of absolute value is? Old school. We got one person. We got one absolute value guy. That's it. We got one person. Nobody else. Everyone else, I might as well say, time like hot. What? Okay. You know it? You remember it?
Yeah.
Anybody else? Kind of remember it? What was the distance from zero? And so that makes it always positive, right? So if I gave you this, it would be, okay, and if I gave you this, it would be, right? We all know that, okay? So look here at the top of page 5, and they give you the definition. I'm going to write this down. They give you the definition, and they say something to this effect. So what the heck, man? What is that? How is that the same as what you guys just described? Use examples if you need to. Why is that exactly what these two guys said? Examples are nice to when you're describing. Right? That's just the absolute value definition there on page 5. This is actually going to be important for those of you that count next year. Why is that the same? So the first question then is, what is A allowed to be? What is it? Could be positive. Could it be positive?
Yeah.
Sure. Could it be negative? Sure. Does it have to be an integer? No, it does not. There's no restrictions on it. So it's any real number out there, right? Okay. So if I pick 6, are we in the top or are we in the bottom? We're in the top. And so then it says if we're in the top, it's just the same thing, yes?
Is it so like it could relate to it as a negative or positive?
Okay, so if it's a negative number, so if I pick -3, what are you supposed to do with that -3? You're down here, so then if it's -3, what does that thing out front tell you to do?
On front where?
Like this. So it's a negative number, right? So it's a negative, but then I just plug in a negative. So it's a negative times negative, so it makes it positive. But that's what you already knew it did, right? Okay, so this is math, right? This is math talk for what you guys just described. Is it okay?
Yeah.
Okay. So, you're maybe saying, like, why take something so simple and make it complicated? And I would say, well, this is actually more efficient than anything else. But you got to be able to read it to know what the heck you're looking at. Okay? So, again, I want to do that. Properties of absolute values down there at the bottom of page 85. I think that should be fine. I'm not going to spend too much time looking at that. So flip over to page 7. You ever seen those things before? Commutative property, associative property, distributive property. Okay, good, right? They're all still true. All right, let's move up then. Because we're going to read some more math. Properties of 0, you can't divide by 0. I think you guys all know that. All right, so this is actually not a horrible question, but like, again, it's like doing what we just did. It's math talk again. So we're going to kick it around here. So I'm right here on the properties of fractions. Now I want you guys to explain what these statements mean. You already know it. It's just like absolute value is more difficult than this. But you know, this is fraction stuff. So the first one is equivalent fractions. And I'm going to take a side note here in a second. But it says A over B equals C over D if and only if AD equals BC. So like, what do they do? Like, what are they saying? It's okay. Why would you not be able to tell me? You can tell me. You guys are smart kids. Don't make it harder than it is. You've done this. You guys actually want to do this like all the time. Like we've been together. You guys see fractions. You just want to do this like all the time. You're gonna see one. Huh? Yeah, that's just cross multiplying, right? That's all it is. You guys like love cross multiplying, right? All you do is say A times B. Oops, where am I? Right, A times B, or A times D says AD, B times C is BC. That's all it is. Right, you guys, like, it's just cross multiplying. Now they got this special thing in there. It says if and only if. So I want to take a sidebar before we continue on. Good job, by the way. Little sidebar real quick. This is like, most likely you've seen this kind of stuff in geometry. But it's true no matter what. Symbols are super cool if you know, you give it up for symbols. Anyone in the front? The symbol fans? Alright, so, have you guys ever seen this before? Yeah, this is read if then. Okay? You go both directions. This is if and only if. Okay? So here's how it's in practice. Let me move this over a little bit. Deer in road. Stop. Well, let's say try to stop. How about that? Try to stop. Alright? So if there is a deer in the road, then you try to stop. Makes sense? Okay, so does it make sense that if you try to stop, there's a deer in the road? You're shaking your head up in the front. Why does that not make sense? Yeah, you might be stopping for other reasons, right? Okay, so that's an if then. So let's do an if and only if. In car, wear a seatbelt. If you don't wear your seatbelt, do not tell me. But if you're in the car, then you wear a seatbelt. If you're wearing a seatbelt, then you're in the car. Now, I don't know, some of you weirdos maybe wear seatbelts when you're not in the car. I don't know, but for the most part, could you say that this goes both directions? There's your if and only if. Is that okay? All right. That's what I like about you guys. What's that? I believe that, actually. They put you wear a helmet at all times. They put you in a little seatbelt. They're worried about you when they're younger, I can tell. Like, our option is that we have to wake up every night and pick him up off the floor, or we can just strap him to the bed, and then we can just get our sleep too. Your parents are wise. Sleep is important. Rules of signs, what are they saying there? That's math talk. You guys already know this. Everything on this picture, you guys know. What are they saying? Well, that's number 6. Multiply straight across is number 6. Yeah, very good. Thank you. Yeah, so right, what he said is, if there's a negative right here, if your fraction is a negative, it can go up top or it can go down to the bottom. It doesn't matter. That's what it says. You guys knew that already, but that's math talk for it. Good job. Equivalent fractions. How are these two the same? They say they're equivalent. Why?
Because they're both just being multiplied by c.
And so then, what? Like if we were over on this side and we're going to this direction, so from right to left, what would you want to do with those c's? Cross them out because they cancel, right? Same thing over themselves. You can cross them out and become 1. All equal signs are if and only if, which is kind of cool. If you're into that kind of stuff. Which I am. All right, what about this one, number 4? It's easy stuff. You guys seen it 100 million times. I was counting. Okay.
You would just add A and C together.
Because,
The same denominator.
right, if you got the same denominator, all you're doing is adding the numerators together, right? That's all it's saying. What about, what's the difference between that one and number 5?
They have different denominators.
And so then what do you have to do if you're adding and they have different denominators?
Put them in a fraction.
So yeah, you got to get a common denominator, so you multiply your denominators together, but then whatever's over here needs to be multiplied by the same thing, right? So that's AD, BC. It's kind of like cross multiplying, but don't hurt my ears. 6 multiplying straight across. 7 keep change flip. Is that what it is? Keep change flip? Yep, I call it dividing. All right, you guys are awesome. Is that what? Is that what? All right, so we're ready to do some homework. So let's get to, what? We're ready for it? What? What, you guys want to do math tests again? No, you're in the wrong place, bud. This is called pre-calc, which in Latin means homework. Look it up. Google Translate that. Good, it's true. All right. Google Classroom tells me that I believe it's 1 through 5 odd. And then and I'm going to do some of these with you because I like you guys. At least they pay me to say that. But you guys are mostly okay. All right, let's do some. The thing about this book is it's super good, but sometimes the directions are like, "Heh." And so let's make sure we know what we're doing. I'm going to do number 1 with you from the aforementioned likability. Oh man, I'm doing that. All right, here we go. A, B, C, D. A is natural numbers. What are natural numbers again? Oh, on a side note, instead of me pacing around the room looking at your homework like I've done before, I just want you guys to take a real quick picture of it, upload it to Google Classroom for me. Please crop it a little bit so I can actually see what I'm looking at. Good. A is natural numbers. What are natural numbers again? I'm getting sick. There we go. Yeah. Positive whole numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Category B is integers. That's add a 0 to it and take all the negatives. Category C is rational numbers. We can write them as a fraction. Category D, irrational, cannot be written as a fraction. So, here we go, negative 9. Is negative 9 a natural number?
No.
No. Is it an integer?
Yeah.
Yeah, so we got to put it there. Is it a rational number?
Is that even not that rational?
Yes.
Yeah.
Yes, it is. Is it an irrational number?
No.
No, but let's not put it in that category then. Negative 7 over 2, is that a natural number?
No.
Is it an integer?
Yeah.
Negative 7 over 2 is not an integer. An integer is negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, etc., etc. But is it a rational number?
Sure.
Is it a fraction?
Yeah.
Yes, sir. Is it an irrational number? No. Okay, good. 5, is 5 a natural number?
Yeah.
Yes. Is it an integer? Oops.
Yeah.
Yes. Is it a rational number?
Yeah.
Is it an irrational number?
Yeah.
No, you can't be irrational and irrational. All right, 2/3 integer. I'm sorry, 2/3 natural?
No.
Integer?
No.
Rational?
Yes.
Irrational?
No.
All right, good job. Square root of 2. Natural? No.
No.
Integer?
No.
No, it's not, because it, type it in, it gives you some weird thing. Rational, can you write it as a fraction? No. So then is it irrational then?
Yeah.
You got it. All right, 0. Natural number? Ooh, that's a tricky one. No, it's not actually. 0 is a whole number, not a natural number. It's tricking you. Gotta stay on your toes, boys and girls. Not picking on the boys and their toes. On a side note, my wife likes soft feet, and she got this stuff. I don't know if you've seen this stuff before. She put her foot in a bag a couple of days ago. There was stuff in the bag, and nothing happened then. And last night, skin is coming out. Do you know what I'm talking about? Skin is coming off the bottom of her foot now from before.
Why?
I don't think she likes soft feet. I like her feet soft if I had a preference, but I wonder, is that safe to do?
You like feet?
Well, I mean, I don't dislike feet.
Do you like rubber?
Well, why not? She's my wife. I don't know. Sometimes her feet touch mine.
You guys like
Airlock code.
No, but I might try that this weekend, though. That might be a good time.
It goes hard.
Her feet will be soft. Mine, I'm not sticking my foot in that bag. I'm telling you what, man. I've seen what it does to the foot. So,
Yeah.
anyway, that has nothing to do with what I'm talking
Tall?
Yeah.
That's tall?
I want to try it.
about. I can, you want me to text her?
Yeah.
Yeah. Please do that. I also like soft feet.
There you go.
My toes are my
Now, don't do it like a week before a game. Also, you guys have no skin on the bottom of your feet. I'll just call that foot stuff.
Yeah. Foot stuff.
Makes your skin fall off. Fall off. Question mark. All right, we'll get that answer for you here. You guys can all get some rub feet together.
Yeah.
All right, where are we at? 0. Well, anyway, so 0 is not a natural number, but it is an integer. Is it a rational number?
Year.
You got it. It cannot be an irrational. And finally, 1.
Yeah.
Yes, yes, and yes. Okay, that's how you're doing the first few problems. Is that okay?
Yeah.
All right, we're jumping down, doing number 13 together.
What are the questions?
It's on Google Classroom, but it's also, it's only like 25 problems or something.
Then for what?
That's page 10 and 11. All right, let's jump down to 13. This stuff is like almost embarrassingly easy. I don't want to, it says plot the two real numbers on a real number line, then place the appropriate inequality sign between them. And so they just got 3 halves and 7. And so as far as I'm concerned, as long as you get them in the right order, then I'm pretty happy. But some people like to get more involved there. So which one is greater? Yeah, so then, right, then that means this way, alligator, it's a bigger thing. Remember that? Crocodile if you don't like alligators.
So
Pac-Man if you really don't like it.
we can write all those three things for one.
Yeah, I mean, I know that's a lot, but you're in the tough math. She just said it's a foot peel mask. Foot peel mask.
It's not fun.
Oh, that was weird. Maybe I'll take a picture of it and send it to you guys.
Peel mask?
Foot peel mask. Yeah, foot peel mask. It was just like, it was like giant blisters and just like falling apart. Yeah, it's not for the squeamish. All right, let's look at number 19. Yeah, I did. Sorry. It was just a number line. One was bigger than the other. Sorry. 19.
That'd be so fun to peel off.
Yeah, if you're into that kind of stuff. You're into like when you sunburn, you just like peel off the layer. That's disgusting.
Oh, yeah.
Yeah.
Not bad. I think so much on my back.
Yeah, that's a weird thing.
Yeah, you did.
You know it's not good for you, right? That's like your body going, something's wrong. I wish my wife did her foot, so I know. She showed me last night, she was all proud. Look, it's finally working. It's like, that's even weirder. But it doesn't work right away, right? It chemically burns for a while, and then sloughs off. Okay. Verbally describe the subset of real numbers represented in this inequality. Okay, verbally, do it. Yeah, verbally, like with words.
X is less than or greater.
All right, so I'll make it a little bit more interesting. All real numbers that are less than and equal to. Oops, sorry.
So you have to write like our we just put X is less than or greater than.
You need to get the questions right on the quiz if I ask it.
Where's the quiz?
I don't know. I didn't do this chapter last year, so I'm not sure when. I think I got it like halfway through. I think I got halfway through this first chapter. What else are we doing? Sketch a subset on a real number line. Well, that's not too bad, right? That's like this. So now, this is what we usually do, right? Now, the book is going to introduce those little square brackets, and they do like this. And then the question asks, is it bounded or unbounded? If I told you this was unbounded, why would you say it's unbounded? Yeah, that's a good question. So, can someone explain what bounded or unbounded means?
I'm guessing bounded is not equal to, because the number is, the only way I can say it's bounded, it's not part of the subset.
Okay, so you're getting a little too involved. This is what I was doing earlier. It's a little too involved. Because basically what he's saying is if you're looking at this, it would be bounded here but unbounded here. Okay, but this, since it's unbounded at all, we're just going to call it unbounded. Sorry, since it doesn't end on one direction, we're going to call it unbounded. Is that okay?
No.
Well, so do you agree that it keeps going this way forever and ever and ever?
Yeah.
And that there's no end to it, no boundary to it, so then it's unbounded?
So that means
If there was 2 points to be bounded,
That's correct. If there's like, if we put something here, so like if you're looking at the book, like 25 and 27, those are going to be bounded because they got them. And it doesn't make any difference if it's included or not included.
so it can be unbounded if it goes right or positive too, right?
Correct. Yes. So it's not because it's going left, it's just because there's no other stopping point. Is that okay with everyone?
Yeah.
All right. I think the rest of them are probably pretty easy, so go ahead and continue on, and I will